I am Dr. Ramanuja, working as Assistant Professor, Department of Mathematics, Marri Laxman Reddy Institute of Technology and Management. In the previous modules, I started discussion about 3.1 module like Rolle's theorem, 3.2 module 2 Lagrange's mean value theorem and their geometrical interpretation. Further, same 3.2 module, I am going to extend example problems related to the Lagrange's mean value theorem like inequalities. Okay, let us start. In the previous class, I discussed about 3.2 module, Lagrange's mean value theorem and their geometrical interpretation. Further, I am going to continue the statement, and with their geometrical interpretation, I will go with one or two example problems. Already we discussed about the statement of Lagrange's mean value theorem. What is Lagrange's mean value theorem says? Let f is a function defined from the closed interval ab to R real number system. This function is f of x is a function which is continuous in the closed interval a comma b. F of x is a continuous in a closed interval a comma b, and also f of x is differentiable in the open interval a b. Whenever there is a continuous in between the intervals of a and b, there exists a point C between A and B. We need to calculate f dash of C is equal to f of B minus f of A divided by B minus A. Already I discussed about there. It's a geometrical how to represent f dash. F dash is nothing but here is the slope. Further, I'll go for the geometrical interpretation of the Lagrange's mean value theorem. Already you know, in this case, f of a value and f of b values are not equal. We assumed that x equal to a and x is equal to b. We need to calculate f of a value. We need to calculate f of b value. This is the difference along the y-axis. This is f of b. This one is f of a. Here is the difference is b minus a. What is the slope of this curve now? What is the slope f dash? F dash of c is equal to the difference of f of b minus f of a whole divided by difference of the y coordinate, which is b minus a. See here, what we observe, when we draw C value between A and B, at this particular point, I can draw a tangent. This tangent is parallel to the chord. This is geometrical representation of the Lagrange's mean value theorem. Further, I am going to extend. Our previous class I discussed about the three problems. Further, I am extending one more problem, which is using Lagrange's mean value theorem. Lagrange's mean value theorem using this inequality, using mean value theorem 1 by 5 root 3 plus pi by 6 less than sine inverse of 3 by 5 less than 1 by 8 plus pi by 6. We need to prove this inequality. Before going to the inequality, let us define the function first. After defining the function, this function is continuous in between the real number systems of A and B. I am going to prove the first inequality. After proving this inequality, I am going to substitute some numbers, whatever the given numbers, I am going to prove this inequality. Let us assume function f of x is equal to what? Sine inverse of x. This f of x equal to sine inverse x function, which is continuous in the closed interval a comma b. I am taking first unknown values a as a and lower limit a and their upper limit is b. Therefore, f of x is continuous in closed interval a comma b, and also f of x is differentiable on open interval a comma b. There exists a point between a and b, point C. There exists a point C between open interval a comma b. We need to take this open interval a comma b. We need to calculate the value of C. See what Lagrange's theorem third condition says, f dash of C equal to f of b minus f of a whole divided by b minus a. We need to calculate what? F of b. We need to calculate what? F of a and b minus a. Already we know b minus a is the values of the interval values. Okay. F of x is equal to sine inverse x. I can substitute A value, it becomes what? Sine inverse of A. This becomes sine inverse of A. And also, if I substitute B value, this becomes sine inverse of B. Now, we need to calculate f dash of C. What is f dash of C? F dash of C equal, what is the derivative of sine inverse x? 1 by under root 1 minus x square. Okay, we need to substitute f dash of C. F dash of C is equal to 1 by under root 1 minus C square. Further, what we observed from this boundary values of A and B, C lies between always A and B. Okay, let us take f dash of C value. What is f dash of C value? 1 by under root 1 minus C square, which is equal to f of B value. What is f of B? Sine inverse of B minus what is f of A value? Sine inverse of A whole divided by B minus A. Okay, now we got the condition f dash of C value. F dash of C value equal to how much? 1 by under root of 1 minus C square equal to sine inverse of B minus sine inverse A whole divided by B minus A. Let us go with the inequality condition. Already I told C value always lies between A and B. Already I proved the case where C is always lies between A and B. Okay, I am going to make their square of these values. Is inequality, it never gets changed. Okay, if I made multiply with the minus A square less than minus C square less than minus B square, now the inequality is reversed. If I subtract with this 1 minus A square greater than 1 minus C square greater than 1 minus B square. If I apply the square root of these values, 1 by 1 minus A square greater than under root of 1 minus C square greater than 1 under root of 1 minus B square. I can use this as a reciprocal of these values, 1 by under root 1 minus A square less than 1 by under root of 1 minus C square less than 1 by under root of 1 minus B square. Already we know the value of 1 by root of 1 minus C square. Look the previous value. What is 1 by root of 1 minus C square value? Sine inverse B minus sine inverse A divided by B minus A. Now I am going to substitute this 1 by under root of 1 minus A square less than sine inverse of B minus sine inverse of A whole divided by B minus A into less than 1 by under root of 1 minus B square. Okay, if I interchange this inequality, which is B minus A whole divided by under root of 1 minus A square less than sine inverse of B minus sine inverse of A less than B minus A whole divided by 1 minus A square. Now we proved the inequality, which is sine inverse B value always lies between B minus A by under root of 1 minus A square less than B minus A by under root of 1 minus A square. Still we need to prove these particular values. This inequality must be satisfied. Okay, let us take A is how much and B is how much. We need to substitute in this case. Okay, let us assume, you can use put B equal to how much B value now? B value how much I am going to substitute now? B equal to 3 by 5. B equal to how much? 3 by 5. And also I am going to substitute A equal to 1 by 2. In this inequality, this becomes 3 by 5 minus 1 by 2. This is the numerator value divided by under root of 1 minus A square. A square is how much? 1 by 4 less than sine inverse of B. B means how much? 3 by 5 minus what is A value? 1 by 2. Sine inverse of 1 by 2 less than B 3 by 2 minus 1 by 2 whole divided by square root of this inequality is B square. This inequality is b square. What is b square value? 1 minus 3 square means 9 by 3 square equal to 9 by 25. 9 by 25. Now, let me simplify this one. What is the numerator LCM? Is 10. 10 it becomes what? 6 minus 5 whole divided by, if I take LCM, this becomes root 3 by 2 less than sine inverse of 3 by 5 minus sine inverse of 1 by 2. How much 1 by 2? It becomes sine inverse of sine pi by 6 less than, this also becomes the same, which LCM is, so this is 3 by 5, LCM is 10, this becomes 6 minus 5 whole divided by, if I take LCM, this becomes 25 minus 9, 16 by 25, which is 4 by 5. If I simplify this one, this becomes 1 by 10 into 2 by root 3 less than sine inverse of 3 by 5 minus pi by 6 less than 1 by 10 into 5 by 4. If we simplify this one, 1 by 5 root 3 less than sine inverse of 3 by 5 minus pi by 6 less than, if it gets cancelled, 1 by 8. This I am going to remove this minus pi by 6 by adding the inequality by pi by 6. This becomes pi by 6 plus 1 by 5 root 3 less than, this becomes sine inverse of 3 by 5 less than pi by 6 plus 1 by 8. This is about the inequality of this. You can say that sine inverse value is always lies between these boundary of the values. Okay, this is example 1 problem. Let us go with one more example problem for similar Lagrange's mean value theorem for this function. Okay, here he didn't mention about the boundary values also, where this function is continuous in between. Simply he given the values where x is always greater than 0. Okay, show that for any function x is greater than 0, what is the inequality is given? 1 plus x less than e power x less than 1 plus x plus 1 plus x e power x. Let us assume, how do you assume the function? Let us assume the function f of x equal to e power x. Here already is given condition x is always greater than 0. We need to take always positive side of the values. Let us assume f of x is continuous on closed interval 0 comma x. I am assuming the boundary value I am going to fix x. Okay, f of x is differentiable on open interval 0 comma x. F of x is differentiable open interval x. Let us assume f of a there exists a point C in between open interval a comma b. Then what is the Lagrange's condition says? F dash of c equal to f of b minus f of a whole divided by b minus a. Okay, we need to calculate f dash x value, f of b value, f of a value. Already b and a already we know. What is a value now? A value is 0. What is b value? B value is x. Okay, let me calculate f of a value. What is f of x? Let me say f of x equal to e power x. What is f of a? E power a. What is f of b value? E power b. Now we need to calculate f dash of x. What is f dash of x? What is f of x? F of x equal to e power x. What is the derivative of e power x? E power x. We need to calculate what? F dash of c, which becomes e power c. See, now I am going to substitute all the values in this condition. E power c is equal to, what is f of b value, which is nothing but e power b minus f of a value, e power a divided by what is a? A means how much? A means 0. What is b? B means x minus 0. If I simplify this one, e power c is equal to e power b minus e power a divided by x. This is the condition. We know whatever the c value always lies between a and b. What is the lower limit a value now? 0. Okay, 0 less than c less than x. Okay, let us apply e power 0 less than e power uh, e power what now one more condition, e power x is equal to, what is b value now? B equal to how much? E power x minus a means how much? 0, e power 0 divided by x. Let us simplify, e power c is equal to how much? This becomes e power x, e power 0 means how much? 1, e power minus 1 divided by x. This condition we need to apply the inequality. Whenever we need the inequality, what is e power c value? E power c equal to e power x minus 1 by x. Let us take e power c less than e power x. What is e power 0? 1 less than, what is e power c we got? E power x minus 1 divided by x less than e power x. Now this inequality I can move this side, x value, or multiply this inequality by x. What happens? X less than e power x minus 1 less than x e power x. Still we need to remove this minus 1, adding both the inequality by plus 1. This becomes 1 plus x less than e power x less than 1 plus x e power x. Now this Lagrange's inequality, this condition is satisfies. Wherever we, what is the use of this inequality? If you want to calculate any e power values of like a 0.1, 0.2, 0.3, in such a cases we need to use this inequality. This inequality values always lies between 1 plus x less than or equal to 1 plus x e power x condition. Okay, this is about the Lagrange's mean value theorem. Further, we will extend one more problem, and also we will apply the same Lagrange's condition in this case. Okay, let us go with third problem. Prove that b minus a by less than log of b minus a by a for 0 less than a less than b. We need to take always positive values, and also hence show that there is a one inequality is also given. Let me prove this first result, then we need to substitute some values of a and b. Okay, let us define the function. See, whenever we need to define the function, let f of x is equal to, let us assume f of x equal to what? Log x. Already in this condition, this inequality always boundary values lies between a and b. Therefore, f of x is continuous on closed interval a comma b. F of x is a continuous on closed interval. This is the first condition of Lagrange's theorem. And also second condition, f of x is differentiable on open interval a comma b, always differentiable in open interval a comma b. What is the third condition? There exists a point c, which is there exists a point c between a and b, open interval a comma b. What is the condition there? F dash of c equal to f of b minus f of a whole divided by b minus a. Okay, for this we need to calculate f of b value, f of a value, b value, a value. Already is given, a is a and b is b in this case, no need to substitute. F of a equal to log a, f of a equal to log a, and similarly f of b equal to log b, f of b equal to log b. For this case, we need to calculate their derivative. Already we know the derivative of log x. What is f dash of x? F dash of x equal to 1 by x. We need to calculate f dash of c, which is 1 by c. F dash of c equal to how much? 1 by c. Now I am going to substitute all the values in this inequality, in these values. Okay, what is f dash of c? 1 by c is equal to f of b log b minus f of a log a divided by b minus a. Okay, this is the f dash of c value we calculated, and also uh, c value is always lies between a and b. C value always lies between a and b. A less than, c less than b. Now we need to calculate f dash of c value, f dash of c value in this inequality. In this inequality, what is the condition here? Uh, f of a, c is given, a less than, c less than b, 1 by a greater than 1 by a greater than 1 by c greater than 1 by b. Now, how do you write this inequality? How do you write? What is 1 by c value we got? 1 by c value is nothing but 1 by c value is nothing but 1 by a, 1 by a. Let me use same inequality. 1 by c is nothing but what? I can rewrite this one is log b minus log a. What is meant by log b? Log b minus log a. I can rewrite directly log b by a divided by b minus a greater than 1 by b. If I interchange this inequality, b minus a divided by a greater than log of b by a greater than b minus a divided by b. If I write this inequality in the order, it becomes b minus a divided by b less than log of b by a less than b minus a divided by a. Now, we proved the inequality of this result. Now, we proved this result. Further, now using this inequality, we need to show this condition. Okay, let us go with their conditions. Already we proved the condition of b minus a divided by b log of b by a less than b minus a divided by a. Now we need to substitute a values and b values. Okay, put a equal to 3 and b equal to 4 in this inequality. What happens? This one 4 minus 3 divided by 4 less than log of 4 by 3 less than b minus a. B minus a means 4 minus 3 divided by 3. If I simplify this one, 1 by 4 less than log of 4 by 3 less than 1 by 3. Now we got the inequality by substitutions of a equal to 3 and b equal to 4. Okay, this is about the Lagrange's mean value theorem. We completed up to 3 problem in this module 3.2. Thank you.